So for this demo, I'm going to explain how the A star in our strategy game works. So if I tell this little guy to move, you'll see he'll avoid the obstacle and find his way down the grid. So how does that work? For stars, it's a classic grid-based system. So if you actually click on a tile, scroll down to Pathing, you'll see it has an X and Y, which is just its position in the grid, and then north, south, east, west. All these tiles have connections to all their neighbors. And all that data is fully built when the tiles get created. So that data actually comes from a BP tile. A BP tile actually inherits from a tile class, which is actually a C++, like a U tile. So that's how all that data is generated. But that still doesn't explain how we actually use it. So to fully use it, we actually have this in our entity movement component of the ABS system. That would be a whole other video in its own, how the ABS system works. But you'll find this little node, create path, and you give a start tile and a target tile. Meaning, when I left click here, my start tile is 3, 0. When I click here, my target tile is 4, 4. So when I call that node, it creates an array of tiles that this little guy needs to get to. And the ABS system will then go ahead and make it work. So you'll notice that this tile you can actually left click to get into, because it's actually a C++ class. So to get into that, we'll open up Visual Studio here. Or open it up a second time, because I'm a fool. Okay. And you'll notice, here is the tile class. Sorry, my apologies. Here's the tile class. You'll notice this looks exactly like the editor. The north, south, east, west, and the ID. So this isn't all too interesting. This is just how we store the data on the each tile. And then actually go in here, you'll be able to find your node. There it is, create path. Create path, start tile, and target tile. There's the guy we want. This just goes into classic A star. Basically you check, like, is that even a reasonable call? Create a path here. Open, close list, yada yada. Add all your neighbors. Then keep going through trying to find a valid connection to the neighbors. Now we have functions for like adding starting tiles. A star is a whole nother lesson in itself, but basically it'll evaluate all its neighbors out until it finds the target. Then it'll find the tile that it was last used and walk back. It's classic A star. But so why did we need to do it in C++? The reason for that is this. Or sorry, this one. Because in blueprint land, we don't like Unreal does not like pointers, because blueprints are their own managed memory language that is a whole other video in itself, multiple videos in themselves. So we did C++ so that we could actually get pointers. So whenever we do our classic A star of wandering down the list, we actually assign a parent to every tile. So when you finally find the target tile, you can actually just pop your way back. So the target tile will actually have whoever found him will have his parent linked up, and then whoever found that tile, you'll have his parent linked up, and then you can just follow it all the way back. And it's that back popping that creates the return. Oh god, that was a terrible Control F button. Once you're finally done, you can just return your path by popping the parents all the way back. So, in application, what it does is 3, 0. It will actually try to explore all of it, but eventually you'll find is when it gets to 4, 4, 4, 4 was called by 3, 4, which is called by 2, 3, 2, 2, 3, 2, 3, 1, 3, 0. Because that way you can just find the parents. And when you get all the parents backwards, and then read that list backwards, you now actually have a forward list of where you want to go from. So, because we did all in C++, you have this nice little blueprint node. So anytime you need to find an A star path around our little game, just call create path here, and it'll return an array of tiles. And you're good to go.